Now, we would discuss what is grading. For a root switch or a concentrator, it is not necessary for each incoming trunk to have access to every outgoing trunk. And this is defined by a term which is availability. A case of full availability is the one in which all the incoming trunks have the possibility of having an access to all the outgoing trunks. But in this case, you can see in figure 5.3, we have got two groups coming in, but they do not have access to beyond their allocated 10 lines. For example, the first trunk is going here, the second is here, third is here, fourth is here. 10 trunks are here and 10 trunks are here. Group 1 has only access to these 10 trunks. Although we have got an availability of 20 trunks, but group 1 does not have the capacity to access any of the trunks related to the group 2. Similarly, group 2 has only access to these 10 trunks. None from this group 1's trunks. This diagram shows 20 trunks connected in two separate groups to switches of availability 10. Here, how do we find the availability? Availability is a key term which is normally defined by the term K. How do we find K? Total number of trunks divided by the total number of groups in which it is divided. Here the total number of trunks is 20. We divide it by 2, which is the number of groups. We get availability which comes out to be 10. To improve upon it, that is, if we want to increase if we want to make the system more efficient, what we do is that we connect the end numbers of the trunks to the end number of group 1 to the end number of trunks of group number 2. We are assuming that we are using a sequential surge system, in which first of all the initial numbered trunks are used. The later numbers are used in case the first trunks are filled. That's why we have used the last four trunks of group 1 and last four trunks of group 2 together and made them common. This can also be shown by a grading diagram. The grading diagram is shown in figure 5.4. In this figure 5.4, you can see the terms which are the trunks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. They are sent as singles, while the trunks 13 and 13, 14, 15 and 16, they are common. That's why we have not put any number over here, and these numbers are continuous: 13, 14, 15 and 16. So a total number of 16 trunks are used over here. Although they do not have full availability. We cannot have full availability still, but we have provided improved some availability. We cannot have full availability because all the calls coming from group 2, they cannot have access to the trunks 1, 3, 5, 7, 9 and 11. Similarly, all the calls coming on group number 1 cannot have access to the trunks 2, 4, 6, 8, 10 and 12. So if the total traffic offered by the incoming trunks is, for example, 8 links, each group of outgoing trunk is offered 4 links, and we provide a grade of service of better than 0.01. We can refer this to table 4.1, which shows a full availability group of 10 trunks will cater for 4.5 links with a single full availability group. Table 4.1 shows that 15 trunks are required to provide the same grade of service of for 8 links of traffic. We can check it in table 4.1. Here it is. For an 8 links of traffic, we need and 0.01 grade of service. We need only, this is 8.1. So 8.1 lengths of traffic can be handled by 15 number of trunks if we have full availability. We do not have this case of 2 different groups. We have one single group of with 2 incoming lines and 15 outgoing lines. Then we can have a grade of service of 0.01 with a traffic of 8.1 lengths. We have already said in that example that 4 lengths of traffic is offered to the 2 groups. Now what would happen when we have 2 groups? 4 lengths of traffic and 4 lengths of traffic. For 4 lengths of traffic we need 10. For another 4 lengths of traffic we need another 10, right? But what would happen when we have improved the availability by making commons or doing the grading? We are left with 16 such lines. You can see that we have 16 trunks available, and we are still aiming for 0.01 grade of service. So we can see that we can obtain the same grade of service of about 0.01 by only 16 trunks, which is only one more as compared to a full availability system. Let me remind you that the full availability system is the one in which all the groups have the availability to all the trunks, which is not the case in case here. Here these 2 groups have their own set of trunks or trunk groups. In this case, all these this group subscribers of this group can only have access to these 10 trunks, and subscribers of this group can only have access to these 10 trunks. While in this case, the subscribers of these 6 have only access to these trunks, but these have access to these common trunks. Similarly, these the customers which come over here would have access to these common trunks, while the earlier 6 would have their own opportunity among these 6 trunks. So this is not a full availability system, but since we have made commons, it has improved our efficiency, and we have just increased one more as compared to a full availability system, and we can achieve a grade of service of 0.01.